We've just seen some very basic and important fundamental principles of statistics in action. One is that in both cases, whether you sample 10 or 20 times, the mean of the sample means approaches or verges to the true mean. We know the true mean was 16. We see here it's right on, and 15.99 is also extremely close. Of course, we've repeated this 10,000 times. We've also seen that the width of the sampling mean distribution of a lower sample size has a wider width than the one with a larger sample size, and you should know the law on how to get from the true standard deviation, which is 5 up here, to the one of the sampling distribution. Let's try to verify that our formulas. Here are the numbers written down, the original mean and standard deviation of the true population. I cannot repeat that often enough, are 16 and 5. And here's sample mean, sample standard deviation for sample size 10 and sample size 20. Both cases, the mean of the sample means is very close to the true mean. But what about this standard deviation? We've learned that the sample standard deviation, which is the standard deviation of the sampling distribution, also called the standard error, is simply the original standard deviation, the original one, divided by square root of n. That's it. So let's try this. Square root of 10 is about 3.16. So this should be equal to 5 over square root of 10. Should be close to it. There's no reason to expect it to be exactly equal. And that is about 1.58. And for the larger sample size, this should be approximately 5 over square root of 20, and indeed that is about 1.11. Now maybe I should not have chosen 10,000 averages of those to demonstrate that this doesn't have to be an equal. This should just be approximately true.